Hello, everybody. My name is Mandeep Sester. Today, I am here to present my database project, which is a StoreMaster retail management system for my term project. So, talking about StoreMaster, it is a comprehensive retail management system. It is basically designed for departmental store, convenience store, and this system can be also work for like uh, store inside gas stations and etc. It integrates key operational components into a unified system. Talking about purposes and benefits of StoreMaster is it simplifies operation in retail environments. Second, it combines inventory, sales, suppliers, customers, and employee management. It enhances decision making with real time insights. It reduces manual tasks and operation errors. It improves customer experience with better services. Some of the parts of my database system is inventory management. It tracks stocks level in real time. It avoids overstocking and stockouts. It sends alerts when stock hits record point reorder points. It links products with supplier for seamless restocking. The second is sales tracking and customer management. Sales tracking, it captures all the sales transactions. It links sales to salespersons and the customers. It provides insight into top selling products and sale trends. Customer management. It maintains customer database with contact and purchase histories. It offers personalized offers and loyalty programs, which contains like discounts, offers for the customers who are regular to our store. Supplier and employee management. Supplier management. It tracks supplier information for efficient restocking, manages purchase order linked to inventory. Employee management. It assigns a specific role to employees, example, cashier, stock managers. Similarly, it tracks performance for accountability. This represents the ER diagram, that is an entity relation diagram of my database system, that is store master. Here, basically, I have 9 tables. My first stable, my tables, 9 table, that is customer table, purchase order table, purchase item table, user table, sales record table, discount table, product table, inventory table, and supplier table. Here, if you see the relationship, for let's start with sales record. One user can be associated with many sales record. Similarly, discount product is also associated. One product can be associated with many sales record. Similarly, inventory and product are in one-to-one relationship. User to sales record and discounts to sales record, customer to sales record is in one-to-many relationship. Also, talking about um, uh, purchase order table, inventory table, they both are in many to many relationship. And purchase item table acts as a third table between purchase order and inventory. So that's why inventory is linked as one to many with purchase item, and purchase order table is linked as one to many as shown in the ER diagram. So this is the overall table, ER diagram, and with its relationship with the table for my store management system, that is store master. So talking about some normalization and functional dependencies for my product table, if I know the product ID, I could get the product name, description, price, category. Similarly, in inventory table, if I know the inventory ID, I can get product ID, quantity in stocks. In supplier table, I have like, if I know the supplier ID, I can know the supplier name, phone number of the supplier, and address. And this point I have not added about like phone number also can is unique in my table. So with the help of phone number, I can also access name, supplier ID, and address in the supplier table. Similarly, for sales record, I have sales ID. With the help of sales ID, I can get customer ID, product ID, etc. from sales record table. In user table, if I know the user ID, I can know the name, role, and email of a record. So these are some of the normalization and functional dependency. All of my ear diagram are in 3NF form, that is third normalization form. To reduce redundancy, talking here are some sample queries. Like we have like sample queries for checking the current stock label, identify product needing restocking, retrieving all sales record, find top selling products, listing suppliers with the product that it supplies to our store. So these are some of the queries that we have over here. Later on the project demo, I will be discussing more about our query, the queries that are the functionalities of my StoreMaster database system. In conclusion, StoreMaster integrates all essential retail operation into a unified system. It enhances decision making and customer experience. It streamlines inventory, sales, supplier, and employee management. It reduces error and increases operational efficiency. Now, moving on to the demo of my project, I'd like to uh, introduce my first functionality, that is check current stock level of all the products. So this, the selected one is the query for it. So when I run this query, it will give me the product name, the stock available right now, and also it gives the data of a reorder label. If my, suppose for my sneakers, if my stock is less than 20, that means I need to reorder the product. I can see all the products with its stock, parent stock, and reorder label. Second is it functionality is identify products that needs restocking. So this, the selected query, helps me to find which products need to be reordered. If I am able to run this query, you can see that Gatroid, which stock is 18, which is less than record label. So this product needs to be reordered. Similarly for banana, the reorder label is 35 and the stock I have is 30. So these are the two products that I need to reorder. My third query is about displaying functionalities, displaying the product with the date they were last updated. It shows while running, it shows me the product and last updated. It means, so for like sneakers, we can see it is last updated in 2024 11/23. Similarly, if we go down, we can see that ice cream, it is updated in 2024 11/26. Yogurt, it is last updated in 2024 11/23 at 10 a.m. Similar, this is what it does. And my fourth one is list all the transaction functionalities, list all the transactions with product name, quantity, total price, and the salesperson involved with it. So if I run this query, it will give me like how many like I sold Sprite three quantity for by sold by me. Similarly, if you check over here again Sprite Monday, again if you see Twix, it is sold one. It is sold by Emily Carter. So this is what it shows. And My fifth functionality is shows the total sales that has for a specific product. Suppose, for example, I have taken Sprite. So if I run the query, I could see that my total quantity of Sprite sold is 6, total quantity of revenue sold is 9. At number 6, functionality is displaying total sales revenue for each day. So if I able to run this code, you can see that like for the 28th, for the November 28th, my total revenue is $21. That means on that day I did sale of $21. Similarly, for 27 number it's $19, and for 26 November it's $59, and for 25 November it's $4.50. That's the total sales done on those days. And my seventh functionality, it lists all the suppliers and the product they supply. Like you can see over here, like ABC suppliers, it supplies Snickers, Ritz crackers, frozen vegetables. XYZ supplies M&M's, Goldfish, toothpaste. Global suppliers, it supplies Twix, chocolate cake, shampoo, Coca-Cola, and all. So this is how we can, this is how it will help for us to know which product is supplied by whom. So my eighth functionality is shows the latest purchase details for each product based on the recent order date. So if you can see here, like on 2024 November 24 at time 11 10 p.m. 10:37 p.m. I ordered $10 of Pringles. Similarly, for Nutella, I ordered $7, $750, $700.50 on 24th from Summit Resources. Similarly, Sprite, I did $800 purchase price, and it is done on 24th November by Prime Wholesale. Similar for Pepsi, I did $150.50 on 2024 November on same time. For the sneakers, if you can see, I did a $100 per 20 purchase from ABC supplier at 11/20 November 24 at 22:16 p.m. That is around 10:16 p.m. Similarly, my ninth functionality is to find top 5 selling products in the store. So if you see over here, muffin is the highest selling product with 8 total quantities sold, Sprite with 6 quantities sold, frozen pizza with 6 quantities sold, Doritos with 4 quantities sold, and ice cream with 4. So these are the top 5 products of our store. Similarly, my last functionality shows the very the product that has been sold in a very few quantity. If you see over here, we can see that the Twix, the quantity it sold is 2, Nutella it is 2, and Goldfish is sold 2. Right now, I have set the limit 3. Based on the store requirement, we can change this value. So this is all about the functionality of my StoreMaster database management system. Now, talking about the referential integrity, how we maintain to referential integrity means to make data more accurate. So for that, we have done many kind of things. We have added many constraints in our table so the data we provide must be accurate. Suppose for purchase item, if you see over here, we can see that For the ID, it's not nullable. That is, ID cannot be null because it's a primary. Similarly, for inventory, it's also it cannot be null. So if you don't add inventory ID, the database will fail to add the data. Similarly, it goes for the purchase order ID. It's also null. Suppose if I try for inventory table, you can see that to maintain one-to-one relationship, we have made product ID also unique. What unique does is if it will not accept what is the value present in that column always should be unique. So if for one inventory ID, if I add same product ID twice, then it will show an error. So in this how one-to-one relationship is maintained over here. So these are some of the relationship constraint that we have done in our database in my store master table. Thank you so much for watching my demo video and my store master's database description. Goodbye.